Hi, today I'm going to explain about the topic DEM, Diagnostic Event Manager. This is one of the component in AUTOSAR and part of DCM. DCM, Diagnostic Communication Manager, is an AUTOSAR module in ECU software which handles the tester diagnostic functionalities like UDS, KWP and OBD. You can see in this picture that DEM has the dependency on fewer modules, that is system services, communication services and memory services. In system services we have ECU state manager, FIM, function inhibition manager and DLT is the part of DCM, and the DEM will interact with the DCM which is a UDS services. So all the UDS services will come under DCM, and the DEM has connection with the memory services, NVRAM, communication services, DCM and system services, ECU state manager and FIM, and the DEM module will come under the ECU software. It is nothing but a basic software. I already explained in the previous video. The AUTOSAR has three layers. One is BSW. Below the BSW we have MCAL, which is microcontroller abstraction layer. Above the basic software we have RTE. We will just do configuration, some interfaces, and we will create a interfaces, and using that interfaces the communication will happen in the basic software and the application software. This is the main use of RTE. The main use of RTE is nothing but it will create the interface or communication between the basic software and the application software. In AUTOSAR, the DEM component is vital because in the entire AUTOSAR layer, whatever in the system and the software, all the components will use the DEM interfaces, or DEM callback functions will be used by all other components in the AUTOSAR. Okay, DEM is one of the important component in AUTOSAR. Then what is DEM? So already I mentioned that the DEM is Diagnostic Event Manager, will be used for other components to log the errors. For example, car will be running and suddenly something has happened in the car. So the error will log. Something happened like low voltage or high voltage, or something happened in the dashboard, the DEM will log. So for each component there will be some specific functionalities will be happen in the each component. For example, consider in the filter service. In the application software monitor we have VDY, which is vehicle dynamics. This is separate component and algorithm functionalities will happen. So those functionalities will not happen correctly, then there will log a error by using DEM callback functions. Okay, next one, why we need DEM in AUTOSAR? It is a standardization. All ECU functions in AUTOSAR use the same interfaces. So we have one specific interface by that DEM, like DEM underscore report error interface, followed by each functionality respective to the components. From the DEM we have only same interface that will be used by all the components to report the error and follow the same rules to reporting the errors. The other components should have some rules when report to the error, like to log an error or to report an error. Whenever there is a malfunctioning is happening in the different components in an ECU, then the DEM event to report the error. So this is the DEM explanation, but we have to see some set of rules also, like debouncing, aging, and everything. I will explain all those things in my upcoming videos. I will give one clear example using DEM. Like for example, we have many components in the AUTOSAR. In that, DEM is one of the component. So whatever error occurs in the ECU, some fault will happen in the ECU. Something happened in the ECU. So whenever the fault happened in the ECU, the DEM should log, and the DEM is used by all the components, and the DEM is having a unique interface, that is DEM error status followed by each component. For example, like high voltage, low voltage, high temperature, whatever, it should be followed by the DEM error status. So this interface is used by all the components to monitor the DEM events. I just give a callback function from DEM. What is the job of the DEM then? First, I will configure one DEM event. I will link that DTC to one DEM event. The people who are working in embedded or else automotive domain, you should know what is DCM and DTC. I will explain all those things in my upcoming videos. DTC is nothing but diagnostic trouble code. So I mentioned that I will configure one DEM event and I will link that DTC to one DEM event with respect to aging, debounce. Aging, debounce are the parameters. I will fill the parameters and I will make ready with one respective DTC. Then my next job is nothing but I have to generate the callback functions. The callback function is used by all the components. Okay, so I will give one example as per my requirement. I have some 100 requirements. I have to configure 100 DTC, 100 diagnostic trouble code, and 100 DEM events, diagnostic event manager. And I have to link one DTC to one DEM. And I have to map everything. I will keep reading and I will generate the callback functions. So based on the requirement, which DEM event should be monitored by which component. So that will be based on the requirement only. Okay, what and all requirements you will get, based on that only you are going to map and you are going to do everything. Okay, I told that I got 100 requirements. So in that I will explain about one requirement, how you will configure how you will configure one DTC and one DEM event for one requirement. For example, voltage related will be monitored by FCU. It is my one requirement. Understand clearly. Voltage related will be monitored by FCU. FCU is nothing but functional control unit. It is nothing but communication stack. I will explain all those things in my upcoming videos also. So they will going to monitor the DEM events. When the supply voltage, I told now it's related to voltage. When the supply voltage is less than 9 volt, the DEM will log that monitor should be taken care by the COM. When the supply voltage is more than 16 volt, then it will be high voltage should be appear. That kind of monitor in the COM. Similarly, based on this all requirements, they will log the DEM events. So the DEM have some rules to follow to report the error. The rules are debouncing, aging, snapshot sampling, diagnostic interfacing, and NVM storage, then finally function inhibition manager. All these things I will explain in my upcoming videos. Thank you.